Hey guys, in the last video we learned how to simplify radicals with variables. Today we will be simplifying radical expressions with addition and subtraction. So let's try. 5 square roots of 3 plus 2 square roots of 3. What does that equal? Well, whenever we need to add or subtract radicals, we can only do that when the radicands and the indexes are the same. And we only add the coefficients, not the radicands. We do this because 5 square roots of 3 is the same thing as 1 square root of 3 plus another 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 square root of 3. Not 5, my mistake. That is just 5 times 1 square root of 3. And 2 square roots of 3 is just 1 square root of 3 plus another square root of 3. Since we're adding them together, 5 square roots of 3 plus 2 square roots of 3, simplest form would just look like that. That equals, if we count how many square roots of 3 there are, 1, 2, 3, 4, 5, 6, 7. So they both equal 7 times that we added square roots of 3. Meaning it was just 7 times square root of 3. We got that from there, but we can also get it because 5 plus 2 is equal to 7. So our answer of 5 square roots of 3 plus 2 square roots of 3 is just 7 square roots of 3. What if we had 2 square roots of 6 plus 2 square roots of 24? What would that be? The indexes are same, but the radicands aren't. Square roots of 6 are simplified, but 2 square roots of 24 can still be simplified into 4 square roots of 6. Now the radicands are the same, so we can add them. So now we have 2 square roots of 6 plus 4 square roots of 6. 2 plus 4 is 6, so our answer would be 6 square roots of 6. 2 square roots of 6 plus 2 square roots of 24 is just 6 square roots of 6. Let's do some practice problems. Negative square roots of 12 plus 3 square roots of 27 minus 3 square roots of 20. Well, square roots of 12 isn't simplified. So we can break it down into 6 and 2. 6 can be broken down into 3 and 2. Circle our primes, and we'll see that there's a pair of 2's. So we'll bring it to the outside. So now we'll have negative 2 square roots of 3. 27 isn't simplified either. It can be broken down to 3 and 9. Circle our primes. We'll see that there are 3 3's, but we'll bring one of them to the outside. So now we'll have 9 square roots of 3. 20 isn't simplified either. So we can break it down into 4 and 5, and then 2 and 2. Circle our primes. We'll see that there's a pair of 2's, and we'll bring that to the outside. So now we'll have negative 6 square root of 5. Now we have 2 radical values with the same radicand, so we'll simplify that. Negative 2 plus 9 is just 7. And then we'll add on our radicand, and then our other radical value. So that is our answer, 7 square roots of 3 minus 6 square roots of 5. Let's try negative square roots of 5 plus 2 square roots of 3 minus 2 square roots of 5. There are 2 radical values with the same radicand, so we'll simplify those. Negative square roots of 5 is just negative 1 square roots of 5. Negative 1 minus 2 is negative 3. Square roots of 5 plus 2 square roots of 3. Since nothing else can be simplified, this is our answer. What about the square root of 3 plus the square root of 6? What would that equal? Well, the square root of 3 can't be simplified, and neither can the square root of 6. So our answer would just be the square root of 3 plus the square root of 6. 5 times the square root of 3 plus 3 times the square root of 12 plus the square root of 8 plus 3 times the square root of 2. We know that all the indexes are the same, but none of the radicands are the same. So let's simplify. 5 square roots of 3 can't be simplified, but square root of 12 can be, into 3 and 4. 4 can be simplified into 2 and 2, circle the primes, and find our pair. Then we'll add it back into the expression, but simplified. So 5 square roots of 3 plus 6 square roots of 3. Then the square root of 8, the square root of 8 can be simplified into 2 and 4, and 2 and 2, circle the primes, and find our pairs. So the square root of 8 can be simplified into 2 square roots of 2 plus 3 square roots of 2 because that can't be simplified anymore. Now we have the same radicands. 5 plus 6 is 11 square roots of 3, and 2 plus 3 is 5 square roots of 2. That is our answer. Let's try 8 6 roots of 5x minus 5 6 roots of 125x. So the indexes are definitely the same, but the radicands aren't. So let's simplify 125x. 125 can be simplified into 5 and 25. 5 is prime, but 25 isn't. 25 can be simplified into 5 and 5. Find our pairs, and then write it simplified. So now it would be 8 6 roots of 5x minus 25 6 root of 5x. Now all we have to do is just subtract. 8 minus 25 is negative 17. 6 root of 5x. So our answer, 8 6 root of 5x minus 5 6 root of 125x, is negative 17 6th root of 5x. That's how to simplify radicals with addition and subtraction. I hope I helped in making math a little less hard for you. Bye!